Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Ladies and gentlemen, welcome back to another video or to another live stream. Okay, so I'm not sure if my viewers are active at this time of the day. And I didn't really live stream for a quite long time now because I got a job these days. Pretty much after the LLVM video, so. But yeah, let's see. Hold on, let me share the live stream though. Okay, copy video URL. Pretty much today we're just gonna be playing some of my favorite video games. And if you don't know me, like I really don't enjoy like video games without any educational value or at least a value in real life. It's like at least as a grown-up man at this point, I like video games that really goes ahead and teaches you something, or at least, makes your brain work a bit. It's not like just, like lazy video games, pretty much. Like, for example, here's the games that I very much like 7 Billion Humans, there is Euro Truck, there is Grey Hack, maybe Bitburner, Human Resource Machine, Kerbal Space Program, Logic World, MHRD, OpenGTD, Chinzen.io, TIS 100. So these are pretty much my favorite video games. And if you have checked all of them, they're pretty cool. So at least in my opinion, you may find them boring. Depends on your own way of doing things. As we say in Germany, moing. What is that? And hello, welcome IPGA. So I'm not sure which video game I'd like to play with you guys today. So there's 7 Billion Humans, there is Human Resource Machine, and there is Chinzen.io and TIS 100. I'll probably go first with Human Resource Machine, and then later on we could check out 7 Billion Humans, and then after that, I guess TIS 100, and then Chinzen.io. It's like, if you don't know, I kind of like ordered them in order of kind of like difficulty in some sense, to some degree. But yeah, pretty much let's, I guess, start with Human Resource Machine. Oh well, I haven't installed it yet. So let's install it. Okay. So if you are just starting to, like, you just want to learn, you're just starting in the programming world and you just want to learn programming, I very much recommend this video games that I have just mentioned. They're gonna give you, like, at the very least, they're gonna teach you how you should think like a programmer at the very least. But it's kind of like you're gonna see in a second. It's like a kind of a simple assembly kind of thing. But yeah, once we get into the game, I can explain more what I mean. And of course, if you have any questions, let me know. I'm also going to try to give you more information, more details on what I'm doing. Though if you'd like to play the game, I don't know, you may want to play it first, then watch this live stream, it's just so... oh my god, okay. Just like you can have all the fun instead of watching me do it all first. Whatever. Anyway, this is just stupid stuff. Anyways, mail room. There you go. All right. Okay. Welcome to your first day. You look like an excellent instruction follower. Your first job will appear over there on the right side in a moment. Okay. right, remember you can always ask me for help. All right, so drag commands into this area to build a program. Your program should tell your worker to grab each thing from the inbox and drop it into the outbox. Sentis, welcome to the live stream. Please come back to Zig videos. I was learning a lot from your Zig videos. Yeah, currently I just got a job, so I'm pretty busy at the moment. So I have just pretty much, I think today, that I just like to play some programming video games pretty much. But yeah, I'll surely do some Zig and Rust videos in the future. But yeah. Okay, so all right. So basically, it's kind of like you're programming this, well, what it seems like a doll or whatever you want to call it. But basically, it's like the CPU essentially. And here you give him like the instructions, and then he should basically do it. But anyways, so I'm just gonna tell him to inbox and then outbox, and then you can run the program. And it's just, well, not enough stuff in the outbox. Management expected a total of 3 items, not one. So basically, I told him to inbox and outbox, but apparently that wasn't enough because I just, he's just inbox and outbox once. So I should actually get the 3 of them. So, well, I'm just going to repeat myself 3 times. And let's go. And you can see this arrow right here, which shows you like the instruction counter kind of thing. Like, it just shows you which instruction you are going through. Just to show you even more, there's this. This is kind of like the debugger in any language you're gonna find in programming. You're gonna work with the debugger a lot. But here you go. So like, for example, you can step instruction by instruction and see what's happening. So here we go. I'm gonna step on one. There you go. Here's the inbox. And here we go. Here's the outbox. Here's the inbox. Here's the outbox again. And yeah, pretty much stuff like that. And you can notice that indeed some instructions takes more time than others. In the assembly world, that may be similar to the how much cycles the CPU takes to execute an instruction. But yeah. So anyways, let's just go forward to the next level. This is just the first basic level. Okay, let's continue to the elevator. Busy mailroom. Well, looks like you made it this far. Congratulations on your promotion. Most people stress out and quit before making it this far, but I can tell you have a bright future in inbox, outbox management. Inbox, outbox. Well, in the programming world, it's going to be input, output management. Because pretty much as programmers, we get input, from input devices pretty much. And then we have to do some processing on that input, which is actually our job as programmers. And then basically we take that processed input into the output. It's kind of like a function. We're like mathematicians, like we just have to make the formula. We get an X and we have to figure out somehow to make a Y. But yeah, anyways, here's your new assignment. Grab each thing from the inbox and drop each one into the outbox. You got a new command. You can drag jumps arrow to jump to different lines within your program. With this new ability, you can complete this assignment using only 3 tool commands. Pretty much, of course, jump is also exists in assembly languages, and you could just drag that up. And yeah, so right now inbox and outbox, and if you remember, we could just like do multiple inbox, outbox, but you can see that this is pretty inefficient. And in this case, it's not practical because, well, we don't know how much items they're gonna be, and we just like it could be even infinite, theoretically. So we don't really know. So what we're gonna do basically, inbox, outbox, and then we're gonna make a jump instruction. If you're coming from the programming side of things, you'll recognize that this is a while, like an infinite loop, a while true do, or while true do something. So like it goes inbox, outbox, then it jump back. Inbox, outbox, jump back. If you're coming from C, you're gonna recognize it as go to with the label here. But yeah, pretty much. And there you go. So right now, whenever it reaches the jump, it will jump to the place it needs to jump, and it will go. It's just gonna go ahead like every time, basically. This program will run infinitely, but of course, because of the game actually ends when you finish your task. But yeah, just like a program, although it is infinite, but it will halt when you're done with the program, when you close it. But yeah, copy floor. Oh no, the inbox conveyor system is completely broken. But that doesn't mean we get to take a break from work. Okay, you can see that we have some other stuff right here. So ignore the inbox for now and just send the following three letters to the outbox. Letters bug. The facilities management staff has placed some items over there on the carpet for you. If only there were a way you could pick them up. Okay, we got a new instruction, copy from. You could just see it here, walk to a specific tile on the floor and pick up a copy of whatever is there. Well, just take a moment and think about what this could be. But basically, this would be similar to a RAM in a computer, basically, as you'll see in a moment. So we can copy from, and then we give it an index, either 0, 1, 2, 3, 4, 5 of the slot. It's kind of like the address in some sense, or the pointer to where you want to get the value. You could also think about it as variables, but yeah. So, okay, so we need bug. So copy from 4, which contains B, and then we're gonna outbox that, and then we're gonna copy from U, well, it's inside 0, and then we're gonna outbox that, and then we're gonna copy from G, and then we're gonna outbox that. Let's go. And this should do the trick. The first time I found this game and I played it, it was so much fun. Oh my god. So yeah. And it keeps on getting more challenging with time. Like even if you're an experienced programmer, at some point you have to make your brain work basically. So the conveyor system is fixed, and just in time for you to get to work, the data won't collate itself. Okay, so grab the first two things from the inbox and drop them into the outbox in the reverse order. Repeat until the inbox is empty. Whenever you hear repeat, you should immediately think about a jump or a while loop or whatever, but basically a loop. You got a new command, feel free to copy to wherever you like on the carpet. It will be cleaned later. Copy whatever you are currently holding to a specific tile on the floor. Now, what I'm currently holding, like the hands of this dude right here, is similar or analogous to a register, to the CPU register or accumulator, depends on where you're coming from. It can be called multiple things. But yeah. So so basically we need to inbox two things every time and like infinitely. But first of all, before we actually outbox them, we have to actually reverse them. So let's see how we can do that. Well, we got an inbox, and the thing is, we don't want to outbox this first thing first. It needs to be the second. So we need somehow to actually store this, so we can actually get the second first, then outbox that. Why? Well, I mean, we need to store it somewhere because we cannot hold two items at once. We only have one register, which is the hands of this dude. He can only hold one item right here. So I'm gonna inbox the first one and I'm gonna copy it to my RAM or to a variable. I'm gonna store in a variable. And then I'm going to get the second item. I'm going to outbox that immediately because that's the first one that should be in the outbox or the output. And then when I'm done with that, I'm going to copy from what I've stored. Basically, I'm going to fetch what I've stored before, and then I'm going to outbox that. And that should do the trick. But of course, at the end of the day, so this is basically what needs to be done, the whole algorithm or the whole procedure that needs to be done to work with like two items at a time. But to actually repeat this, infinitely, we have to jump back to the first instruction. So we kind of like repeat the program from scratch. And let's go. As you can see, we have stored the first one, and then we got the second one. We immediately outputted that, and then we have just got back the first one and outputted it, basically. So yeah, pretty cool. Your presence is requested on the next floor. Okay, coffee time. I really don't like these cutscenes. Come on, can I skip them? uh, yeah, programmers are pretty much likes coffee too much, as you can tell. Okay, so rainy summer, year six. Welcome to my personal rain cloud. I was never very good at math. Me neither. Since I have only 3 fingers on each hand, well, that makes sense. At least I have 5 fingers, so. But I hear you don't actually need to know very much about math to complete these assignments. And well, oh well. You don't really need math to actually start programming. Well, you do need some basic arithmetic. But other than that, pretty much nothing crazy. In fact, programming will probably be better than your school teacher at teaching you math at some point. It's like, for example, especially graphics programming like shaders. Oh my God, you cannot believe how much advanced math I learned there because of that. So yeah, but pretty much when it comes to programming, you're just gonna find libraries which contains the operations that is needed to do some mathematical stuff. For example, let's say derivatives and integrals and stuff. Instead of learning how to calculate those, which the computer will actually do that job for you, so you don't need to learn that. And also, someone else have already probably made the algorithm for that, so you could just pick up a library that someone else have made or a function that someone else have made, and then you can use that. But what you really need to know there is when to use something and why it would benefit you and when, etc. So basically an integral is to like find the area in the function curve or whichever. And you could use that for all sorts of things, but basically you just need to know like not everything, but you need to know as much as tools as possible. You don't really need to know like how it works underneath. It could be just a black box. It doesn't matter. Anyways, so for each two things in the inbox, add them together and put result in the outbox. So you got a new command. It adds the contents of a tile on the floor to whatever value you're currently holding. So in the assembly world, this would be analogous to, well, the add command. So a tile on the floor. So basically some value in your RAM or in your memory to something you're currently holding, which is something in the register or the accumulator of the CPU. But yeah, like you cannot really add two items in the RAM directly. Uh, well, at least not the advanced ones. Sorry, the basic CPUs. There probably could be some advanced CPUs that can do that, but yeah. Anyways, so let's actually inbox and add them together. And we're basically gonna copy because well, we cannot hold two items at once. We're gonna first of all copy that to the RAM, and then we're gonna basically take the second box and we're gonna add it to the value we have stored, and then we're basically going to outbox it. Well, yeah, outbox it because we're gonna be holding the accumulated value in the register, which is the hands of this little guy. So yeah, and then we're basically going to repeat that infinitely. By the way, math in the computer is pretty fast, but what is slow is mostly memory and input and output. As you can see here, like you have to travel some time, in this case to the RAM, and then from the RAM to other place, etc. And like the ad, it's pretty much just, in place to very fast. As you know, like the RAM is quite far relatively to the electric speed or the energy speed. But anyways, zero exterminator. So this is pretty much or just like kind of like challenge branch. But anyway, zero exterminator. Where do you see yourself in 5 years or 10 years? I have a note here from your other boss that says, from this point on, your performance will be evaluated with extra scrutiny. What a trait! And here we go. Right now, we are actually have some competition going to actually minimize the instruction count as much as possible and to have the fastest solution as possible, basically. So yeah. Send, and that's where also like a strong mathematical knowledge could actually help. Like you can in fact program your whole life without really having any advanced math. You could just always figure out something or use some library. But when you have like a very good foundation on mathematics, you could pretty much make a lot of cool solutions. It's like advanced, efficient, fast solutions sometimes. That helps in that regard. But anyways, send all things that are not zero to the outbox. You get a new command. It jumps only if the value you are holding is zero. Otherwise, it continues to the next line. You get a new command. It jumps only if the value you are holding is zero. Otherwise, it continues to the next line. So, well, first of all, we got the input and output. Then we got the RAM, the variables. And then we got operations, arithmetic operations. And then in fact, before that, we got the jump, which is like loops, right? Now we got if0, which means, well, conditionals. So now we can actually make decisions in our program. Because of the jump, we can actually repeat stuff in our program. And yeah, pretty much. So there are not zero to, okay, let's inbox. And if the zero, we're gonna jump essentially. So there are not zero to the outbox. That are not zero. So I guess we could just go back and inbox again. Otherwise, we could go ahead and outbox, I think. And then finally, we could just repeat. Rinse and repeat. So it could be more efficient. I don't know. Let's see. Okay, notice that when, oh, yep, there you go. Okay, let me show you step by step for a second here. What's happening? So basically, we're taking the inbox, then we're jumping here if zero. We're jumping to the start of the program if zero. Now five is not zero, so it's not gonna jump. It's just gonna ignore it and goes right into the outbox. And right now, we're gonna jump back to the start of the program because we need to start again the procedure. So we have again an inbox, of course. Now it is a zero. Now jump if zero would actually jump because what we're holding in our register is actually zero. So now we're just gonna throw that value. Basically, we're gonna override it. And we're gonna get another item at that point. And we're just gonna go ahead and do the trick. And yeah, and that process will just go further and further like that. Pretty much. Yeah, I don't think this could be more efficient. I don't know. 4. So your current solution uses 4 commands, and your solution completes in 32 steps on average. Okay. These challenges can be very difficult, in many cases not possible to optimize both simultaneously with one solution. Now, this is something like, yeah, sometimes you can actually optimize things, but sometimes you have to make trade-offs. Um, like you could add more instructions, which basically means you're adding to the program size in the cost of actually making your program faster. Sometimes you can do some optimizations that would lower the program size, basically less instructions, but slower speed. So it depends on the trade-offs that you want to make, and that's basically what a software engineer is supposed to do. It's like you just gotta weight all these stuff and figure out the best solution. Because really, the actual coding is not that challenging, but pretty much just solving problems and finding the best trade-offs. And but yeah, it has come to our attention that Zero Advocacy community felt the previous assignment was not inclusive. This time, send only the zeros to the outbox. What happens to the other numbers and the letters? Management leaves that detail up to you. Okay, so we're just gonna throw them in the trash. Send only the zeros to the outbox. Okay, pretty cool. Pretty simple. So like, just gonna invert the jump of zero here. So instead of going back, what we could do, we could, well, just go directly, I guess. Outbox. Actually, here's the deal that we could do. Like, well, if zero, but we're gonna need 2 jumps. I wonder if I could do it with 1 jump. I probably can. Let's see. I don't know. Let's just first of all solve this. Okay, so jump if zero, outbox, and jump again, and there you go. Let's see. So there you go. Basically, what's happening here, we're getting a box. If it's zero, we're jumping from the jump. So we don't jump back immediately. Then we go to the outbox, and then we jump again. Otherwise, if this is not true, if it's not zero, then we're not gonna jump. So we're gonna jump back to the to the start. Uh, complete in 25 or fewer steps. Interesting. Hmm. Modern assembly. Hello, Ridwan Karti. Welcome to the live stream. I'm great. What about you? I'm pretty great. All right, so how we could actually optimize this further? Jump if zero. Hmm, great to hear. So, unbox jump. Well, I guess let's not waste time on optimization at this point. Okay, return to game. Yeah, there is a good quote that they say, like, premature optimization is the root of all evil. You're gonna hear this a lot, pretty much. So you could pretty much waste a lot of time on optimization. Yeah, we don't have that time right now. So let's just return. Well, let's go. How do you? Oh, I see. Oh, you could actually do this. Okay. Sub hallway. Okay, so let's see. Subtraction. I never learned that in school. Pretty relevant. I never learned that in school. Did you? Mm, I don't know. We're a good team. For each two things in the inbox, first subtract the first from the second and put the result in the outbox. First, subtract the first from the second and put the result in the outbox. And then subtract the second from the first and put the result in the outbox. Repeat. Rinse and repeat. You got a new command. Subtracts the contents of a tile on the floor from whatever value you're currently holding. Okay, so we got a new command called sub, which subtracts the contents of a specific tile on the floor from whatever you are currently holding. The result goes back into your hands. So basically, the value that you're currently holding, which is in the register of the CPU, this little CPU right here, um, is the first value, like in the subtraction, and the second value is the one that's going to be on the floor or whatever. Okay, so basically, let's inbox, I think, and then maybe copy two, so you can get the second item. So basically, we're gonna copy it, well, store it or cache it in a variable or the RAM, and then we're gonna get a second item, and let's try to sub this from that item that we stored, and then we're going to outbox. And let's just see what's gonna happen. Is the order right or not? The order is not right. Okay, so I should probably then store the second item too, because I think they're expecting the opposite to happen first. So let's actually store that too. So just to not confuse you, basically we're back into getting the second item. Then we're going to copy it to, well, a second slot because we don't want to overwrite our first value, that's for sure. And then after that, we could actually copy from, like, fetch our first item and then subtract it from the second one. And then try to outbox that, I guess. Let's see. I don't know what order they exactly want, though. Oh, no, it's actually right. It's actually right. It's just that, yeah. Never mind. Okay, hold on. So let's just go back to what we were doing before. Sub 0. But now I do need that actually. And yeah, I do actually need that because I do have to do the second calculation. So yeah, I do need that. Never mind. And there you go. Control Z is your helper. Okay, copy to, copy from, sub, and then outbox. Let's see again real quick. What? I'm confused. Hold on a second. So I'm getting the first item. I'm copying it to 0. Okay, now I have the second item. Now first subtract the first from the second. So the second should be in my hand, which it is. And then I have to sub from 0, then output that, right? Okay, yeah, that's right. Now let's go to the second step, which that we have to do right now the opposite, which would, I guess, basically results in, like, hold on. I mean, 4 minus 8 and 8 minus 4. So, yeah, this is going to be negative, but we don't have like a negative instruction here. So we just have to do it manually. And for that, we're just going to basically inbox. We're going to copy to the second item too. Then we're going to sub. Then after that, we're going to copy from I think 0, which is basically the first item. And then we're going to sub 1 to the second. And well, we got to outbox this, and then outbox that. Then we're going to jump. Let's see. 4, now it should be minus 4. There you go. And it's going to repeat again. This is pretty much how a programmer should think. Like, this is the foundation of everything, pretty much. Like, you get to know algorithms, you get to kind of know how the CPU kind of works in underneath in a simplified manner, in a gamified way. I very much love these games, and I hope that more games like this would actually get released. Other than that, the trash that we have today. So yeah. So I do still have some other cool games like this in my Steam account, so that's nice. Don't worry about that. Okay, 10, 10, 40, 40. Okay. Let's continue to elevator. Now we could go with the challenge stuff. Well, I don't know if I'm going to figure this out. These tends to be pretty challenging, actually. This optional area is for high-performing employees only. Is that you? I don't know. I mean, we're gonna see. I did actually solve these challenges, I think, before. They were pretty challenging, honestly, but I don't like it was a very, very long time ago. So you're late. 7 years late. We need to make some changes around here. I want to see a 100% performance increase. From this point on, your performance will be evaluated with extra scrutiny. Okay, so for each thing in the inbox, triplet and outbox the result. There you go. We got some multiplication, but the thing is, we don't have like a multiplication instruction. And well, if you don't know, old CPUs at least doesn't really have a multiplication instruction. So you just have to program that with the add instruction and other instructions. So this pretty much means that you're doing like you don't have a multiplication in the hardware. You just have to simulate it or emulate it. I don't know which one exactly in the software. Basically, you got to program it yourself, which tends to be slower, but it works. So yeah, and basically you get like reduced cost on the hardware because you don't have to like add another multiplication chip or multiplication circuit in your CPU, or ALU to be exact. But anyways, so inbox self-improvement tip. Where are we going with this? Please leave the high level decisions to management. They're basically warning you that this is a challenge. It should be pretty simple, I guess. At least for this one. Though the later ones are pretty crazy. Inbox, okay. And now what we're gonna do? We're gonna copy to 0. And then we're gonna get this. Well, we have to basically triple it. Okay. So here's the deal. We're gonna inbox, and then we're gonna copy it to 0. And then we're gonna add it to 0. So now we have multiplication by 2. Assalamu alaikum assalam, local 4 games. Welcome to the live stream. So inbox, copy to 0, and then we're gonna add, which would basically double the value. And now we're gonna add again, which would basically triple the value. And then we're gonna outbox. Well, before we outbox though, we gotta first copy from the result actually. And then we're gonna outbox it and jump. Jump from the window. Okay. As you can see, it triples it. Oh my god, no, 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 no. Okay, we don't need this copy from. I forgot that we actually accumulate. Yeah. Okay, that's pretty cool. There you go. -4. Okay, double, triple. There you go. Pretty cool, huh? And that's the first challenge. This is pretty much very easy, but the other ones, it's crazy. Maybe the other, like the next one, I could probably do it too. But the other one, I don't really know. There's a cool digital logic game if you want to look at it. I think, are you talking about this one? Uh, Logic World? No? Or, well, these are the games that I have currently on my Steam account. I do have some other games on Epic Games, but I don't, well, we could check that out later on, but yeah. Okay, can I post the link? I don't think it would let you. You can post it on Discord server. I think you could find the link in the description. And by the way, please join my Discord server so you can get notified and you can vote for the next live streams. Continue to elevator. Okay, so let's just try Octoplier suit. And let's see. Yes, you can always check your own performance on each assignment's optimization challenges. The 2 green lights next to each button in the elevator will tell you how you're doing. Is there anything in life more thrilling than self-improvement? Okay. Now that's what I love about these games because you are actually improving yourself by playing these games. In like the other games, or like most other games, like when you close the game, it's all done. It's like you have not benefited from anything. You only have that kind of happiness hormones while you're playing that game. But when it comes to self improvement, when you close the game and you still have improved something, um, that's where the other hormones pick up. But anyways, so Fly Moon 2023. Hello, hello. Welcome to the live stream. For each thing in the inbox, multiply by 8, not 3 this time. And put the result in the outbox. Using a bunch of add commands is easy, but wasteful. Now we come to actual optimizations. Can you do it using only 3 add commands? Management is watching. I can. But first, let's just do it the naive way and the inoptimized way, which is just a bunch of add commands, just like before. We're going to inbox the item, then we're going to copy it to memory, and then we're going to basically add it to it. Now here we have doubled, now we have tripled, now we have quadrupled it, I think. And yeah, I think that should good to go maybe. And then repeat, rinse and repeat. Let's see if that's right. 4, 5, 6, 7, and 8. Yeah, that's right. But you're gonna notice that, well, we have a lot of add commands here, but we can actually do it only using 3 add commands with just a little clever trick. It's nothing crazy, but yeah. Which would actually optimize for both the size of the program, which basically would reduce the instruction count, and also it would optimize the speed of the program, which basically means we're going to do less actions to do the same thing, which as you can see. As you can see, we haven't beaten nor the size challenge, or not even the speed challenge. So now let me show you what is the actual trick that we could do to optimize this to just 3 add commands. Now, if you notice here, let me just go step by step. We're copying it to 7, okay? Now, we're adding this, and we're basically just adding 7 by 7 by 7 by 7, which is quite crazy. Now here, if you notice, this is 8, which is a power of 2. So 2 to the power of 3, which is 8. Okay, so what we could do, here's the deal. Like, we could store the actual result that we got back into the memory, and then we could add that, which basically were, instead of just adding 1 by 1, you're gonna see in practice, but basically instead of adding 1 by 1, we're gonna be like multiplying it by itself. It's kind of like exponentially growing instead of just, but you'll see it in action actually. So let's just remove all this crazy stuff. Actually, we're gonna need only 3 add commands, but between each and every add command, what we're gonna do, we're gonna actually copy back the result, the accumulated result, back into memory. We're gonna copy it back again back into memory. And yeah, I think that should probably work out. Let's see. And right now you're gonna see what I mean. There you go. There you go. So that's how it works. So I'm basically using the accumulated result back and adding that. So instead of adding 1 by 1, I'm basically going with the power, like I'm multiplying it by itself again and again. Although, of course, that wouldn't be possible if this wasn't like a power of 2. But you could always just go to the nearest power of 2 and then just add the other ones. But yeah, hopefully that was understandable. And there you go, we have beaten both the size challenge and the speed challenge. In this case, we didn't have to like do any kind of like, we didn't have to make a trade-off between size and speed. We just optimized both size and speed, which is nice. And just a little bit of math, you know, it's not really that much. You know, it's like just power. Just instead of adding 1 by 1, you multiply. You kind of like multiply by itself. Actually, not multiply, but add it by itself. I don't know if I can figure this out in a quick time. I remember this took me a very quite long time to actually figure out. But let's see. Let's just see anyways. Though I'm not gonna waste a lot of time. If I can't figure it out immediately, I'm just gonna go to the next one. So what a wonderful feeling when all your work over the last few years all comes together and culminates in a well-executed assignment. Okay, speaking of this, programming is very, very frustrating. But once you see your whole program running step by step and doing exactly what you want it to do, that's where all the frustration you got just goes away, basically. And there you go. So, all right, now for each thing in the inbox, multiply it by 40 and put result in the outbox. Now it's not 3, it's not 8, it's 40 and we don't have a multiply command. How are you gonna deal with that? Okay, I think I got a little idea, but let's see if it's gonna work. So the deal is I'm gonna multiply up to 32, and then I can also multiply up to 8 by using the same method that I've done in the last level, and just add those together. Let's see if I can do it. Because, well, 40, if you don't know, well, I cannot just use the last method by itself that I've done in the last level, because what's going to happen is that I'm going to go from 8 up to 16, up to 32, up to 64, which is not 40, which is not what we want. So what I'm going to do, basically, as I said, I'm going to use the same trick that I've done earlier to basically like calculate up to 32 multiplications and 8 multiplications, and then add both those results to get 40 multiplications. Okay, let's see how we can do that. So basically, I'm just going to do the last thing that we have done. Let's see how we can do that. So inbox, let's see, inbox. Okay, copy to 0. Then I'm going to add to 0. Then I'm going to copy from 0. Going to add to 0. Copy from, add. Copy to 0, add 0. Copy. And also this kind of constraints that you have just a limited set of building blocks. These limitations that actually goes ahead and makes you creative and makes you go out of your way to do things pretty cool. Like, you know, currently in the game dev world, you just have all these shiny tools and not a lot of limitations. So it's kind of like creativity have, like, you just have like, even though like the technology is very great, like the games are pretty realistic and stuff, but you always feel like they're just cheap clones. But while if you come back to the other, like the old games which are just basically programmed in assembly directly, you know, like the roller coaster one, you just feel something different about those games because there was just a lot of creativity on it. It's not like the games of today, well, at least most of the games. But hopefully you got my point right there. But anyway, so this should basically gives us multiplied by 8. And we're just gonna do it 2 times more to make it into 16 and then to 32. Okay, let's see. Copy from 0, add 0. And again, copy from 0, add to 0. And let's see. So this should hopefully do the trick. Let's see. There you go, 2. Actually, what I'm doing, no, not copy from. Oh my god, copy to. Copy to 0, copy to 0, copy to 0, copy to 0. Okay, so this should do the trick. 1, there you go. 2, 4, 8, 16, and 32. Lovely. As you can see, we got multiplication by 32. Right now, what I'm going to do, I'm going to leave that result. I'm going to put it back there, I think. Hold on. Yeah, I'm going to put it back. So copy to 0. And I'm just going to leave this result, this multiplication by 32. Now I'm going to go ahead in another slot in memory. I'm going to actually calculate the multiplication by 8. Or otherwise, hold on a second. Oh my god, I have another crazy idea. But let's just do it the straightforward way first, and then I'm going to show you even better optimization that I have just thought about right now. Can you do 4 plus 4? What do you mean? But anyway, let's see. then add to 32. What I'm going to do basically right here is I've already multiplied by 32 at this point. Now I'm going to go ahead and calculate multiplication by 8 and then add that. Later on, I'm going to show you even more brilliant trick here. But let's just go step by step in the optimization. Okay, let's see. So let's right now basically get an inbox again. And this time what we're gonna do, we're gonna copy to 1. We're gonna keep the result that we have calculated for the multiplication by 32. So inbox, copy to 1, add to 1, copy to 1, add to 1, copy to 1, and add to 1. There's a clever trick later on, but yeah, I don't know if you can think about it. But yeah, anyways, so copy to 1, add 1, copy to 1, add 1, copy to. So we have 1, 2, 3. Okay, so this should be good enough. Now we got basically multiplication by 8. Now what I'm gonna do, I'm gonna add that back into the multiplication by 32 that we got here. And that should hopefully do the trick. Now outbox and jump. Let's see. So we're doing the multiplication by 32 right now. And we have just stored the result. Now we're going to do the multiplication by 8. And finally, we're going to take that and add that to the other result that we got. What happened? Bad outbox. Management expected 160 but outboxed 80. So yeah, I've done something wrong probably. Let's see what's happening. Oh yeah, I see. Copy to 1 here. Actually, no, hold on. That's kind of weird. I'd like to test with 1 because it's pretty simple what's going on there. I'm just gonna keep on playing until I get a 1 because it's much easier to reason about. Come on. There you go. Okay, let's see. So as you can see, we got the multiplication by 32 done. Oh my god, hold on. Yeah, I see what's happening here, in fact. I'm not supposed to actually inbox another number. I'm actually supposed to work with my first number that I actually used. Okay, okay, I see. I see what's happening here. So here's the deal. I'm gonna copy from, let's say 2, and I'm not gonna inbox here, of course. Or actually, you know what? Copy from 2. In fact, I don't even need to do that, right? Um, Copy from 2. I could just go directly and put it in the first one. Okay, gotcha. So, okay, copy to 1. So let's just remove all this. Okay. And now what we're gonna do basically, we're gonna copy to 0, but we're also gonna copy to 1. So we use the same number. 2, 3, 4, 5. That's kind of look weird, honestly. Yeah, that kind of look weird. Oh well, I kind of didn't get it right. Hold on. Inbox, copy to 0, copy to 1 here. I'm adding, add, add, add. Though I'd very much need another one, or I'm just doing something wrong here. Hold on. Okay, let's see what's happening. 32. Okay, what's happening there? No, 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 no. Hold on. Go back, go back, go back. Something is going wrong here. Okay, so we got 32 here. Okay, what's happening now? Oh, right. I'm not supposed to do that. I'm gonna copy from. Add one, and I'm copying it to there. What? Oh, okay. Okay, before adding one, gonna copy from one. Yeah, I think this should work now. Did you guys understood what I'm going for right now? There you go. That's what I'm talking about. Okay, focus right now because minus one is pretty easy to reason about. So there you go. I got the 32 multiplication and I just left it. Right now I'm going to do the multiplication of 8 and then I'm going to add it back with 32 and now I got multiplication by 40. You see what I've done there? I think it's pretty clear from the that one right here. Did you guys understand? Well, 0 is 0. Now here we could have done some optimization if it's 0. But I don't know if we have that instruction because as you can see, well, we're just spending CPU time at this point on 0. So if it's 0, just don't do anything. Just directly give the result. But as you can see, we could optimize it even further. And I know how. Basically, we're kind of doing the same kind of thing over again. Here's the deal. So instead of doing the multiplication by 32 and then again doing the multiplication by 8, what we're going to do, while we're multiplying by 32, we're going to reach a point where we have the result of the multiplication of by 8. And now we can basically store that here. And then we're just going to continue the 32 like nothing have happened, the multiplication by 32 like nothing have ever happened. And then we're going to add that back to the stored result of the multiplication by 8. And then we're going to outbox and we're going to get 40. So we don't have to repeat ourselves in the second way. But anyway, let's see. So we don't need copy to here anymore. And we also not going to need this anymore, I think. So it's basically 1, 2, well, it's basically 2, 4, 8, 16, 32. And then we're copying it to 0. No, don't do that. Okay, so we got by 32. Now, basically, 2, 4, 8. Now here, while we're coming here, like at this point, we got the multiplication by 8, so we could just store that. And we could go further with the other one. Let's see if I can get a 1 because it's much easier to reason about. So I can show you how that basically works. Come on, give me a 1. Well, it's coming here. Come on, what? Okay, there is a problem already. Okay, I really need that one. Hold on. Come on. It's a 1 by 10 chance of getting that. Okay, let's see. So we got 8. Now we have stored back the result. Oh yeah, I have to add back that. I forgot about that. Add 1. The one that we stored, the multiplication by 8. Now this should do the trick. As you can see, I stored the multiplication by 8 and then I've just continued to the multiplication by 32. And then finally I've added both together. Oh yeah. And 0, we're just losing out on cycles there. And there you go. I almost got the size challenge. I also almost got the the speed challenge. But yeah, I don't have though a conditional, so I cannot really do much about this. But basically, here's the deal. Let me show you one thing. Well. What is it called? Yeah. Let's see if I can bring my new tablet. Let's go. So I can hopefully explain to you what I'm doing here. So I can show you my little my ugly handwriting. Okay. There you go. Connected. Hey, we're doing some art. Yeah, we're doing some mathematical art. Okay, let's go. So let's see if this actually works. All right, let's go. Nice. Okay. So here's the deal. So basically, before, when we want multiplication by 8, what we have done, like we got 1, and then we basically had that box, right? Which contained that one. Now, what I've done at first to just triple, I just said 1 plus 1 plus 1. Oh, okay, hold on. Plus 1. But in the second level, what I've done is that instead of 1 plus 1, I have stored back the result into that memory. So instead of adding 1 again, I add double the value, which is 2. And then I add 3. Now this combined gives us multiplication by 8. So 3, well, what I'm doing here. Oops, sorry, not 3, 4. Because this, basically I doubled this, right? Because I stored it back. I stored the result back and then I added. So basically we got multiplication by 8, just using 3 add commands and by storing back the result before adding, instead of just keep on adding the same value. Now here, when I wanted 40, I cannot really do much because if I use this, if I keep on using this kind of strategy that I've used in the second level, and sorry for my bad handwriting, but basically, what's going to happen is that I can reach 16, which is fine, and then I can reach 32, which is also fine, but then afterwards, instead of going to 40, if I use the same strategy, I'm going to actually go to 64, which is, of course, not what we want. We want 40. So what I've done, I've used the strategy that I used in the second level to get the multiplication by 32. And, oh, okay, I forgot about the 8 though. So, and I also used the same strategy to get the multiplication by 8. And well, you know that 8 plus 32 is, well, oopsies, is equal to, well, 40, right? So I got what we want. But then afterwards, I figured out that, well, I'm just repeating some work, what it is. Because basically, while I was multiplying to get the result of the multiplication by 32, I already got the multiplication by 8 in the process. So what I've done, I just stored back that result that I got. Well, basically, here's the deal. So to actually reach 32, I had to actually keep on adding, like keep on multiplying. Now to reach this 32, I had to go through all of this, the results of all these multiplications. So what I've done, while I'm going through to get the multiplication by 32, what I've done, I actually stored this result in another memory slot. I just basically stored it in another variable, so I can come back to it later on. So after that, I just continued the operation like nothing had happened until I reached 32. Now, once I got the results by 32, I have added both these guys to get the multiplication by 40. Hopefully that makes sense. Hopefully that makes sense. Oh well. Hold on a second. Does that make sense? So we're basically, because we're storing back the result, we're getting like powers. Instead of just multiplying, instead of just multiplication, like basically in the other strategy that we have done in the first stage, what we have done is 2 times 1, 2 times 2, 2 times 3, 2 times 4, let's say, 2 times 5, etc. In the second stage, to multiply by 8, what I've used is that instead of multiplication, I actually used powers. 2 to the power of 0, 1, 2 to the power of 1, 2, 2 to the power of 3, 8. And I got my multiplication by 8 just using 3 add commands. And by storing back the result so I can add the same thing. Because, well, when it comes to powers, what I'm doing basically is 2 times 1, and then I'm basically 2 times 2, right? And then I got 4, right? So 2. 2 goes here, and then the 4 goes down 4 times itself, equal to, well, 8. And then again, we use the 8 to multiply by itself, which gets us 16. No, hold on, what the? Hold on. I'm doing it wrong. Hold. What? 2 times 2, 4. Hold. No. No, I'm doing this wrong. Okay, never mind. But hopefully that made sense. So basically we're using powers instead of multiplication. But yeah, hopefully that made sense. So now I'll just go back to the game. Pretty much. So let's just pass this. Yeah, why can't actually? There you go. And yeah, we're done with this challenge too. And we pretty much have completed these 3 challenges. Although the third one, it seems like it can still make it even better somehow. I don't know how. But yeah. I mean, if I think more, I could probably figure it out. But anyways, let's just not waste time. Equalization room. Sometimes some numbers are bigger than other numbers. Um, okay. And sometimes they are the same. How can we know? I read about that here in this great book, Which Number Are You? For the aspirational zero. You can borrow it later, sure. Okay, now we got comments, which are basically just, oh well. I have my tablet right now, so I could just write stuff. Oopsies. Hello. Okay, pretty cool. So this is how you do comments essentially. So, all right, so get two things from the inbox. If they're equal, put one of them in the outbox. Discard non-equal pairs. Repeat. You got comments. You can use them if you like to mark sections of your program. Okay, so comments, you just use them to like remind yourself or make some notes of you, for yourself and for others that reads your code. Okay, so now the thing is, we do not have a conditional to know if something is equal to itself. We only have a conditional to check if it equals to 0. So how we can actually check like if it's equal to itself? Like if two numbers are equal, just by checking if something is 0. Well, it's actually pretty simple. I don't know if you actually got it. If you realize how already. Oh well, I'm just gonna use my mouse right now at this point. Okay. Let's go. Okay. So here's the deal. I'm gonna inbox the first value, and then I'm gonna store that, of course. Then I'm gonna outbox the second value, and then I'm gonna subtract it from the first value that I stored. And if that subtraction is equal to 0, which means that the first value and the second value is are equal basically, because well, if you subtract two numbers and you got 0, which means those two numbers are actually the same number. That's as simple as that. So if 0, that means they're equal. Put one of them in the outbox if they are equal. Okay, otherwise, if they're not equal, we're just going to discard them. But if they're equal, what we're going to do, we're going to copy from, because right now we got the result, which is 0. We're going to copy from the value. And it doesn't matter which one is it, the first value or the second value. In fact, the second value, we don't even have that. We only have the first one. But it doesn't matter because they're the same value, pretty much. So we're going to basically outbox that. And then, of course, we're going to repeat. Rinse and repeat. Let's go. So 3. We have 3. Okay, we got 8. Now we're going to 8 minus 3, not equal to 0. So we're just going to discard both. Now we got 9 and 9. Now 9 minus 9 is equal to 0. And then that means they're equal. So we're going to take them into the outbox. Does that make sense? I think it's pretty clear. And again, we're wasting cycles on 0. Not really this time, I guess. But anyways. All right. There you go. As you can see, it can be more optimized. But anyways. Maximization room. Did that make sense to you guys? There's been a change of plans. The accounting department has determined that treating all numbers equally is no longer profitable. Well, that was easy because, well, it's not a challenge, you know, it's not in the other kind of, it's not like the other ones. The other ones were actually challenges. This one is just like kind of like the normal progression. The accounting department has determined that treating all numbers equally is no longer profitable. Management wants the big numbers only. Okay, so right now, instead of equal numbers, you have to basically figure out the greater number and output that. How are you going to deal with that? Well, again, but this time you actually have if negative. You also have the jump if negative. So if it's negative, it's going to jump. Interesting. So I think you have already figured it out how we can do that. Like how we can check just using jump if negative if one number is bigger than the other. I think you can already. Did you? Let me know. Let me know. Grab two things. I mean, from the previous level, I think it's pretty clear what's gonna happen next right now. So grab two things from the inbox and put only the bigger of the two in the outbox. Now it's not like the other level, the previous level, which like we only outbox the thing. All right. Knock. Okay, so basically, yeah, as I said, in the previous levels, like if they're both equal, then we're gonna get one of the values. But if they're not, we have to choose one of them. So we basically have to store both. So we're gonna inbox, then we're gonna basically gonna copy to 0, I think. Yeah, and then we're gonna again take the second value and we have to store that too. And now we could basically go ahead and sub the first value and see if it's negative. Now if it's negative, then we're gonna either copy from the first or the second. I don't know the exact order would be, but let's just try it out. So yeah, copy from 0, outbox, and well, yeah, or copy from 1. What? Oh yeah, copy from 1. And then I'm just gonna jump. It's kind of like an else statement. But anyways, jump and then outbox. Otherwise, we could just, in fact, outbox and just jump directly. But honestly, let's just do it this way, I guess. And then just finally jump here, maybe. And yeah. It could be the reverse order, but let's see. 9, and we take the 9 with negative 9 or 0, so we basically take one of them. Yeah, we'll just take the greater value in this algorithm. But there is like a little optimization here, which is what happens when they're equal. When they're equal, you don't want to really do any extra work. I'm not sure if we do though. We probably do, but let's see. Let's see what happens when they're the same. 9, and it puts the 9. If it's 0, what happens? Yeah, it doesn't matter really. Yeah, never mind. So it's fine. Okay. Employee moral insertion. If you guys understood what even those cutscenes mean, let me know. I've never understood. Now we got absolute positivity. Okay. Haha. Positive attitudes were determined to increase productivity and are now therefore mandatory. Smile. Management is watching. Send each thing from the inbox to the outbox, but if a number is negative, first remove its negative sign. Okay. Alrighty. Well, first of all, we have to figure out if a number is negative. If that's the case, we have to well, let's see. We have to basically subtract it twice. I guess. So because if we subtract it once, we gotta get 0. But if we subtract it again, then I guess we're gonna get the positive value. Let's see. Let's see. Inbox, and then we're gonna copy to 0. Then we're gonna, well, it depends if it's negative. Now, if it's negative, we're gonna do some extra work. Though if it is positive, we're just gonna outbox it directly, essentially. So if it's positive, then we're gonna outbox directly and jump back, I think. Otherwise, what we gonna do is probably sub twice, I think, if I'm right. And then we could basically outbox it. And honestly, we could just do this and then jump back. Let's see if that would do the trick. So we got 9. Oh, well, actually, if it's negative, don't even copy. So let's just actually do this. So we're gonna check it directly. If it's 4, what happened? Hold on. Jump if negative. Oh yeah, okay. 4, it directly goes to the outbox. No extra steps. -4, add it, 0, add it again, or actually subtract it. We got the positive value. 1, 0, directly. Pretty cool. -1, subtract it, 0, subtract it again, 1. Positive value. And yeah, pretty cool. Done. That's how you make an absolute value, just using subtraction and if negative. Exclusive lounge. I don't know how crazy this challenge would be, but let me just check it out real quick. Yes, I've always felt most comfortable with nice, cold, logical decisions. Emotional decisions are for the weak. Yep, they're basically hinting to the nature of electrical signals, I guess. 0, it's either powered off or powered on. No in between. In like logic, in like the digital, or is it? Nah, not the digital though. I don't really know. An analog, yeah. Analog signals are like it could be anything in between, just like emotional kind of decisions. But the logical decisions, it's either yes or no. For each two things in the inbox, send a 0 to the outbox if they have the same sign, both positive or both negative. Send a 1 to the outbox if their signs are different. Repeat until the inbox is empty. Though you could see that we have some predefined memory values. Right here, 0 and 1. Okay. Hmm. They have the same sign. Let's just see the other levels and we can go back to this guy if we have time. Go back. Pretty pointless cutscenes. I can't even skip it. Oh, well. Countdown. Yes, welcome back. Tick, tick, tick. Time keeps ticking down. Let's get to work. Oh, yes. I love what you've done with your hair. Oh, okay. For each number in the inbox, send that number to the outbox, followed by all numbers down to up or up to 0. It is a countdown. You got new commands. They add 1 or subtract 1 from an item on the floor. The result is given back to you, and for your convenience, also written right back to the floor. Bump. Yep, there is some related instructions in the CPU. I don't really remember what they're called. I think dec and inc, which stands for decrement and increment, which basically just adds 1 or decrements 1, and they're pretty useful for loops and to keep track of count. For each number in the inbox, send that number to the outbox, followed by all numbers down to or up to 0 is the countdown. Okay, I think that's pretty simple. So inbox, copy to 0. Now basically gonna sub, actually not sub, we're gonna bump minus that value. But though if it's 0, it's already 0, then we can just go ahead directly and basically outbox it, I think. Oh, down to or up to 0. Okay, so it's actually negative. We actually got to do the opposite. We got to add. Interesting. So, okay, hold on a second. So, if it's negative, then we have some other logic to do. If it's positive, then some other logic. So, if negative, then we got to basically add, keep on adding until it's 0. Jump if 0. Okay. Otherwise, we want to bump minus until we reach 0 once again. Bump minus. Mm-hmm. Otherwise, it's just going to keep on repeating until it's become 0. Basically, and here, hold on. Yep, pretty much. And then here we're going to basically jump. Well, actually, yeah, we're going to keep on doing that. But like if it's 0, then we kind of gonna do like a similar thing. Otherwise, we're just going to keep on bump. And then finally, well, in fact, every time we bump, in fact, even before that, we gotta outbox first. Okay. I think that maybe should do the trick. I guess. And honestly, if it's 0, then I guess just go back directly. Maybe not. Honestly, just keep it like that. And then finally jump here. Let's see. 6, we're gonna output 6, then we're gonna minus 1. Oh, no, 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 no. That's not what I want. Okay, so the problem was with the, let's see. So if negative, we're actually going here. What? Oh, in fact, it should be the opposite, right? I guess. 6, 5, 4, 3, 2, 1. I don't know about 0. Yeah, well, I need to include 0 too, though. So let's outbox that too. There you go. What? But you outboxed -1. What in the world have happened there? So I outboxed. Oh, I think I need to jump if 0 directly or something. Oh yeah, I need to jump directly if it's 0. Without actually bumping, I think. Maybe. What? Okay. Oh, outbox jump if negative. Oh well, basically here it could be 0. Let's see, jump if 0. Oh yeah, I think it should be like this. What? I think this should be fine for the other branch because it doesn't include the case where it is 0. There you go. Probably not the most optimized, but it's fine. Continue to elevator. Okay, well, there's still a lot of crazy stuff. Probably um, gonna finish this one. So yeah, I think. Let me just see real quick what's this about. Copy from 0. For each 2 things in the inbox, multiply them and outbox the results. Don't worry about negative numbers for now. You got labels. They can help you remember the purpose of each tile on the floor. Just tap any tile on the floor to hit it. Okay, I see what's going on here. Well, I guess let's just at least do this one. It's pretty fun. Uh, Basically, you get 2 numbers and you have to multiply them together. Only using these commands. But right now we have a more interesting command, which is bump plus and bump minus, so we could actually keep track. Okay, and this is also contains some interesting optimization. Anyways, let's go ahead and just make it work for now. So inbox, we're gonna copy to memory, gonna inbox again, and what's gonna happen basically, well, let's see, we're gonna copy to 1 probably. Let's see. Yes. We also got a 0 here for some reason. Hmm. But anyway, inbox copy to 0, inbox copy to 1. And then I'm going to probably keep on bumping minus and adding. Okay. So, well, bump, jump if 0. Bump minus. Oh yeah, I see. And add to 1. Because I'm still holding the second item essentially. So, and we're going to basically keep on doing that. So jump if 0. That's if 0. Okay. Hold on, what I'm doing here. Jump if 0. What? Well, if 0, we're going to outbox them. Now, the thing is, jump if 0 here. But, well, we got to actually take the copy from from 0, I think, and then jump if 0. Well, in fact, if not 0. So, I think we could basically do something like, I don't know, it's kind of weird, but let's see. So 4, and then we take 5, we put it there. Oopsies, no, 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 no. Alrighty. Copy from, jump if 0, copy from 1, okay, 4, then we add a 4. What? That's crazy. I'm confused. Hold on. 9. Okay, good. 4. I'm taking it up so I can see. Why I'm adding? Actually, I need to add it to 0, I think. 3. Add a 4. Bruh. Hold on a second. Clear. So we're gonna take the first item. We're gonna copy it to 0. Oopsies. Copy to 0. We're gonna take the second item. We're gonna copy it to 1. And then we're gonna check if that's 0. Now, if it is 0, then what we're supposed to do at that point, we're supposed to basically so basically our box, well, we're going to copy from, and in fact, if it's already 0, then we don't even need to do anything at that point. We can just go directly and what? Actually, if it's 0, it's kind of interesting. We have to use this constant right here. Okay, hold on. Copy to 0. Now, I guess we could do something interesting. which is that we could have some sort of like functions essentially. But anyways, so we're taking the first value, then we're taking the second value, and we're gonna see if it's zero. If it's zero, then what we're gonna do basically, well, anyways, if it's zero, then we're gonna basically copy from, or actually, I mean, it's already zero, so at that point we could just output that, right? Could just go directly and outbox that. Now, if it is not zero, then we have to go ahead and copy from 1 and basically, well, what? We're gonna do the multiplication operation, right? I just want a 0 in the second spot, just so I can test something. Oh well, that's never gonna happen. Nope. Okay, so inbox copy to 0, inbox jump if 0. If it's 0, then we're gonna outbox it. Otherwise, we gotta basically keep on bumping. Let's say we're gonna keep on bumping maybe 0. So hold on. Actually, we gotta first of all copy to 1. Then we could just keep on bumping that maybe. Bump -1. Okay, copy to 1 of minus, and we're gonna keep on doing that until copy from 1. If it's 0, we're going to basically go ahead and well, if it's not 0, then we gotta keep on going. So before that, we gotta copy from, bruh, super confused at this point. But anyways, I think it's enough for today at this point. We could like continue this later on. Anyway, so that I think that was it for this live stream. And thank you for tuning in, and see you later, everyone. Goodbye.